Part A. Sodium chlorate crystals are easy to grow in the shape of cubes by allowing a solution of water and sodium chlorate to evaporate slowly. If V is the volume of such a cube with side length x, we want to calculate the derivative of the volume with respect to x when x is equal to 3 millimeters and explain its meaning. So let's take a look at a cube. Well, first of all, let's draw what the cube represents. So if we have a cube, okay, so we have an x here, an x here, and then an x here. Okay, and so what we want to do is we want to find the derivative of the volume with respect to x when x is equal to 3. Okay, so what do we know about the formula for the volume? Well, the volume is equal to x cubed. Okay, and so what we want to do is we want to find the derivative of the volume with respect to x. So what does that equal when we take the derivative of that? When we take the derivative of that, or v prime, this becomes 3x squared. Okay, and so now what we want to do is evaluate this when x is equal to 3. So if we plug in 3 and then square it, well, that's going to give us 27 millimeters cubed per millimeter. So here we can say that the volume is growing 27 cubic millimeters per every millimeter. Okay, now in part B it says, show that the rate of change of the volume of a cube with respect to its edge length is equal to half the surface area of the cube, and explain geometrically why this result is true by arguing by analogy of what we'd have done in exercise 11b. So let's just take a look at the cube here. Copy that. Okay, so first thing is first, all right, we know that the derivative of the volume function gave us 3x squared. Okay, and so we need to look at surface area. So what is the surface area, or the area of that surface there? So we can say that the surface area is equal to what? Well, we have 6 sides, and so that's 6, and then we have an x times x, which is x squared, so therefore that is 6x squared. Okay? And so then what we want to do is we are going to then add some extra parts to this cube. Right? So if we take a look at that, when we add this extra parts, okay, as we go around this entire cube, that means that we're adding a change of x. So that means that each side here, okay, is going to be adding another change of x on this cube. So that means we're going to have x plus the change of x here. We're going to have x plus the change of x here, and then x plus the change of x here. Okay, so what does that tell us? Well, that tells us that we are going to have the volume of the new cube, and that is x plus the change of x cubed. And then we also have the volume of the old, which we know is equal to x cubed. So now in step 5, what we want to do is we want to find the change in the volume. And the change in the volume is taking the volume of the new and subtracting the volume of the old. So we have x plus the change of x cubed minus x cubed. Okay, now remember how you need to cube a binomial. I'm going to go ahead and just write this out, but you want to reference that. So if you cube this binomial, you're going to get x cubed plus 3x squared times the change in x plus 3x times the change in x squared plus the change in x cubed minus x cubed. And so from here we can eliminate the x cubes. Okay, and then what we end up getting is 3x squared change in x plus 3x times the change in x squared plus the change in x cubed. Okay, so therefore that is the change in the volume. Okay, so now in step 6, we want to take the change in the volume and divide it by the change in x. So we can factor out a change of x in this function here. And what's left is 3x squared plus 3x times the change of x plus the change of x squared, and then divide that by the change of x. So we can eliminate that. And so we get the change in volume over the change in x is going to equal 3x squared plus 3x times the change of x plus the change of x squared. Okay, and then keep in mind here that these two here is, or the change of x is small. And therefore, since it is small, we can say that the change in v over the change in x is going to be approximately 3x squared, which is what we got for the derivative of the volume, which was 3x squared.